amount of waves that pass per second. So cycles, how many waves? 20. How many seconds? 10 seconds in total. Therefore, the frequency is equal to 2 hertz, which simply means 2 waves passing per second. And that means that this boat is being hit with 2 waves per second. Let us move on. We're almost at our second to last question. What is the wavelength? Okay, we're at our second to last. What is the wavelength of a BBC radio wave that has a frequency of 99.7 megahertz and a speed of 300 million meters per second, which is 3 times 10 to the 8 meters per second, the speed of light? So these are electromagnetic waves. What we have here, we have the speed, the frequency, but we don't have the wavelength. So let me quickly write down what we have. We have the frequency. The frequency is equal to 99.7 megahertz. And if you remember your prefixes, mega would be 10 to the 6. So 99.7 times 10 to the 6 hertz. We have our speed, 3 times 10 to the 8 meters per second, but we don't have lambda. So lambda is what we're trying to find. The formula to reconcile all three would be V is equal to F lambda. Since we're trying to find lambda, let's make lambda the subject of the formula. Lambda is equal to the speed divided by its frequency. Therefore, we're going to have that lambda is equal to 3 times 10 to the 8. And I won't write the units for the sake of the space that I have. Frequency is equal to 99.7 times 10 to the 6. And let's divide. Our division we're going to be left with 10 to the 10 squared up top. And if we divide 3 by 99, 3 divided by 99.7, we get 0.03 times 10 squared. And this would be in meters. So let me just fix that up a bit. So 0.03 times 10 squared is the same thing as 3 meters. So lambda therefore is equal to just 3 meters. Last question. This last question says, a carpet salesperson uses an ultrasonic device to measure the length of a room. The device shows that the distance from one wall to the opposite wall is 6.5 meters. If the speed of ultrasound in air is 340 meters per second, how long does it take the ultrasound to travel to the far wall and back again? Good question. So we need to remember a few things. In order for this ultrasound to travel to the wall and back, it would have to travel double the distance. So it traveled 6.5 times. Sorry about that. Yes. So we're working with ultrasound. So this should actually be 340 meters per second. Now if we travel the total distance of 13 meters, how long did it take to travel a total distance? The speed of sound in air is approximately 340 meters per second. and this wave, it traveled a total distance of 30 meters. How? Well, if it is traveling from the opposite end to the other end of the room, and it traveled 6.5 meters, in order to travel over that side and back, it would have traveled a total of 13 meters. It would have traveled a total of 13 meters. So in order to find the total time for its travel, we need to write down a formula. So we know that speed is equal to what? Speed in this case, we're going to use v instead of s, is equal to the total distance divided by the total time. If we want to find the time is going to be equal to the total distance traveled divided by its speed. The total distance traveled is 13 meters, and the speed is 340 meters per second. Let's quickly do that calculation and see what we get. So you should have gotten, and we're going to put this to 2 decimal places, that the total time would have been 0.04 seconds. And that's it for